Hello friends, welcome to our another video, and today we are going to discuss uh, different types of dependent source in an electrical circuit. Okay, you will you will get a different type of electrical source in your circuit diagram, and that are as mentioned follow. That is, first is voltage control voltage source, that is this. Okay, so this is your first, you can say, source of dependent source. Okay, voltage control voltage source. The second one is a voltage control current source. The third one is a current control voltage source, and the fourth one is a current control current source. Okay, and remember, this all type of source which you will encounter in your circuit is all a four terminal network component. Okay, what is mean by four terminal? So the internal diagram of this source uh, have the four terminal. Okay, so this is what we called as four terminal. Okay, here is two terminal and there is two terminal, so they together makes a four terminal network. Okay, so let's begin with our first, that is a voltage control voltage source. Okay, so this is the circuit diagram actually of the voltage control voltage source. Okay, you can see here that the A and B point over here. Okay, so the A and B point is applied pardon, the A and B point is applied with some input voltage, that is VAB. Okay, so the input voltage is equals to VAB. Okay, so this is my input voltage, and I will control the output voltage at terminal C and D. Okay, and my output voltage is VCD. So my output voltage is VCD, sorry, VCD. Okay, so I have to control the output voltage VCD by changing the input voltage, that is VAB. Okay, and that is why we called as it is a voltage control voltage source. Remember, this is mm, actually the symbol which you can encounter, which you can see in your circuit. Okay, they will not provide this whole thing, but this the only thing that you can see in your circuit, and you have to guess that, okay, so if I'm looking at this thing in my circuit, so it must be some control voltage or control current uh, uh, circuit, or a control voltage or control current device. So I have to use the relation, which is this. So whenever you see the voltage control voltage source, so the input voltage, the output voltage is controlled by the input voltage with some multiplication factor, that is mu. Okay, you can see over here the mu is the multiplication factor with the VAB. So I can write as the VCD, that is my output voltage, is equals to mu times VAB. Okay, so this is the relation uh, we can establish in voltage control voltage source. Okay, and the mu is called a gain, voltage gain. Okay, and this is a what we can see, a unitless quantity. It doesn't have a unit because it's a voltage gain, and if you want to find the voltage gain, that is mu, you have to just divide output voltage with the input voltage, and you can see the voltage get cancelled. Okay, the unit of the voltage get cancelled, hence the mu is the unitless quantity. Okay, moving to our second thing, that is this, the voltage control current source. Okay, in previous we have seen that we control the output voltage by the input voltage. In this we will see we can control the current, output current. Okay, so the current at output terminal, that is C and D. So the output output current, that is I will write all in short form, is that is ICD. It's looked very big. Let me draw it again. ICD. Okay, so the output current is controlled by the input voltage, that is V, and that is VAB. Okay, so the output current is controlled by the input voltage, and the output current, that is ICD, you can establish a relation like this. The ICD is equals to GM times VAB. Here the multiplication factor is GM, okay, G in suffix M, okay, and the GM is called as transconductance, which is a very very important term in a Hall network theory. Con Transconductor, okay, and it has a unit. Okay, you can guess the what is the unit of GM by just taking the VAB to the other side of equal to. So the current upon voltage, the unit of current is ampere, while the current of the unit of voltage is volt. So the transconductor, that is GM, has a unit, okay, and the unit is amperes per volt. So please remember this, because it's a very important thing in a whole electric network. Okay, so the transconductor uh, is just a ratio of current upon voltage. Okay, the third one, that is a current control voltage source. Okay, as we seen in previous, the input signal we have put purposely the voltage. Okay, but in this we will give the input signal as a current, and will try to control voltage at the output terminal. Okay, so in this my input signal, that is input signal is current, okay, and which is IAB, and my output is, I have to control a voltage, okay, that is VCD, and again we know that we have to multiply with some multiplication factor. Okay, and here you can see the multiplication factor is R. Okay, and what is R we will discuss. Before that, let me maintain a relation, that is output voltage VCD is equals to, is controlled by R times IAB, that is input current. Okay, and R is called trans resistance. Okay, it is another a very important factor you have to remember, that is trans resistance. Okay, so it is called the trans resistance, and you can guess the unit of trans resistance, that is R, is equals to volt per ampere. And you can see it is just opposite of transconductance. Okay, so the transconductor unit is amperes upon volt, and trans resistance unit is volt upon ampere. Okay, it is another a very important factor which you have to remember. Okay, so the transconductance is there, okay, while controlling the voltage at output by the current at input. Okay, and the last one is the current control current source. Okay, so as the name suggests, the input signal must be current, that is IAB at terminal AB, and the output which I want to control is also a current at output, that is ICD. Okay, and I have to multiply with some multiplication factor, that is beta. Okay, you can see over here. So I will write the output current, that is ICD, is controlled by beta times input current, that is IAB. Okay, so sorry for the disturbance, the company call. Yeah, so this is the relation in current control, current source, and the beta is called a current gain. Okay, current gain. In voltage control voltage source, we have seen that is mu. Mu is called a voltage gain. Here it is a current gain, and the beta is another unitless quantity. You can see if you take a input voltage, that is IAB, to the another side of equals to, the amperes get cancelled. That's why the beta is a unitless quantity. Okay, similar to our mu, which is a voltage gain, again a unitless quantity we have seen. Okay, so this is how the four types of dependent source you will see in your circuit, and how to use it, how to handle that source by this thing which we have just seen. Okay, thank you.